Good morning, VYW students. This is a Zoom lesson. So what you're seeing right now is what we would be doing in the Zoom. So if you weren't able to attend your Zoom, make sure you watch this lesson. It'll be very helpful for your Delta Math practice. Also, this is our final lesson of the unit. On Monday, you'll be getting a quiz review, even though we're not meeting on Zoom on Monday. On Tuesday, you'll be taking your quiz for this unit. So make sure you work on your quiz review on Monday. So today's learning target is I can apply the distance formula to determine the distance between a given set of points. So this is one of the new formulas we're learning about, the distance formula. But here's the issue. What exactly is the distance formula? So let's actually figure out how to find it. So the distance formula, we can actually prove and we can actually show. And we actually can prove it by using the Pythagorean theorem. So we know that the Pythagorean theorem is a squared plus b squared equals c squared. Right? A squared plus b squared equals c squared. So what I'm going to do is I have a right triangle right over here. What I'm going to do is I'm going to put my right angle in here. And what I want to do is I want to find the distance between these 2 points, x1, y1, and x2, y2. What I want to do is I want to find the length of this segment, but I can't just count. I actually have to use a formula. And it all goes back to Pythagorean theorem. So you can draw a right triangle and find your distance by using Pythagorean theorem. Well, we know the side across from our right angle is our c value. We know that the sides are a and b, so I have a and b. So what I'm going to do is I'm going to make those substitutions. So where I see my a, I'm going to put x2 minus x1, and we get that by basically saying that, to find your new x point, it's just going to be x2 minus x1, and then we're going to do y2 minus y1 for b. So I'm going to go to my formula, and I'm going to do some substitutions. So we have x2 minus x1, and we're going to put that in for a, so we're going to square it. So we have x2 minus x1 squared plus y2 minus y1 squared. And that's equal to c squared. But if I look at my image, where I have a c, I actually have a d. So I'm going to put in a d for c. Now, I want to solve for d because d is my distance. So what I'm going to do is, to get rid of that square, I'm going to take the square root of both sides. So take the square root, take the square root, and I'm going to put my d on the left-hand side now. And I get d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's your distance formula. And yes, you actually do have to memorize this one. But I promise you it's very, very straightforward on how to use. So that is how we use Pythagorean theorem to find out what our distance formula is. So the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. All right. So the distance formula, the way it works is you're given 2 points, x1, y1, and x2, y2. So what I'm saying is that I basically have 2 different coordinate pairs. And the distance between those points is given by this formula right here, which we just derived. D equals x2 minus x1 squared plus y2 minus y1 squared. And that's all under a radical. Please, please, please don't let those little numbers scare you, which you call those subscripts. They only indicate that there is a first point and a second point. So that is that you have the 2 points. Whichever one you call the first or second is up to you. Order doesn't matter. How I do it is I always just go backwards. The distance will be the same regardless. So please just know that, all right? So let's actually practice using the formula. So the first thing we're always going to do is we're always going to rewrite our formula. So we want to find the distance between the following set of points. So I know my distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So then I always rewrite it. So the first thing I'm going to do is I'm going to identify my x values. So my x values are -2 and -6. My second x value is -2. So again, you can do -6 minus a -2, or you can do -2 minus a -6. But if you're going backwards, you have to stay backwards. If you're going forward, you have to stay forward. So I'm going to do my substitution. And I have -2 minus a negative 6, and I'm going to square it. You're going to notice I put my negative 6 in parentheses. The reason why I put it in parentheses is because it's a negative number. I'm not just going to do negative 2 minus 6. I'm doing negative 2 minus a negative 6. Then I'm going to add y2, which is a negative 10. And I'm going to take away a negative 10. And I'm going to square that whole result. So now let's do some arithmetic. So I have distance is equal to, well, negative 2 minus a negative 6 is really negative 2 plus 6. And negative 2 plus 6 is just 4. So I'm really doing 4 squared. And now I'm going to do negative 10 minus negative 10. Negative 10 minus negative 10 is just 0. So I'm really doing 0 squared. And now I have to ask myself, what's 4 squared? Well, 4 squared is 16. So I have 16 plus 0 times 0 is 0. So what you're really doing is you're just finding the distance of the square root of 6. You're just basically doing the square root of 16 plus 0, which is just 16. So you're just going to be finding the square root of 16. So if you type the square root of 16 in your calculator, you're going to get 4. And that's your final answer. To the side, I'm going to show you how you would do it with double on the inside, single on the outside. And there's the double on the inside, single on the outside. So you break apart your 16 into 4 and 4. You could do 2 and 8. It doesn't matter. And then once you do all your breaking apart, you get 4 2s. Remember, double on the inside, single on the outside. That's how I got my 4. Now we're going to do this example. The first thing we do is we always rewrite our formula. When I rewrite my formula, I just write it as distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to do it the exact same way I did before. I'm going to color code it again. If you want to color code it, you can as well. Makes it look nicer. And I always draw a big radical. The first thing I do is I identify my x2 and my x1. My second x value is a 2. My first x value is a 3. So I'm going to be doing 2 minus 3 squared plus, now we're going to do our y2 and our y1. So 7 and a negative 3. So plus 7 minus negative 3. All of that's going to be squared. So I have distance is equal to 2 minus 3 is negative 1. Make sure you put that negative 1 in parentheses because that's going to change your result when you square it. So I have negative 1 squared plus 7 minus a negative 3 is actually 10. So I have 10 squared. And now I have to ask myself, what's negative 1 times negative 1? Negative 1 times negative 1 is 1. So I have the square root of 1 plus 10 times 10 is 100. What's 1 plus 100? 101. So my distance is just going to be square root of 101. The reason why I can't break apart my 101 is because 101 is a prime number. I can try to do a bunch of factors, but the only factors of 101 are 1 and 101. So there is no way to do a double on the inside, single on the outside. On Delta Math, occasionally it will ask you to write your answer to the nearest tenth. So you would just write out radical 101, and then you would type it into your calculator, and you would get the square root of 101, which is, let me look. Ooh, I have so much on my calculator. 10.04, I'll write it out. Think he does some where you have to do to the nearest tenth. So if I wanted to round this to the nearest tenth, I look at my 0, look next to it. For lower, hit the floor. So my final answer would just be 10.0 as your final answer. It's approximately 10.0. All right, let's go on to our digging deeper. So the coordinates of triangle ABC are A1, 3, B, -2, -1, and C, 5, 0. Find the lengths of each side in simplest radical form, if necessary, so that means there's a good chance we're going to have some radicals in our answer, and find the perimeter of triangle ABC. So the first thing we're going to do is we're going to plot our image, then we're going to connect our points to make our triangle, and then we're going to find the distance of each side. After we find the distance of each side, we're going to add them together. So the first thing I'm going to do is I'm going to plot my points. I'm going to plot the point A13 first. So I'm going to go to 1, up 3. So I'm going to plot A here. Now I'm going to plot B, which is -2, -1. So I go out to -2 and down to -1. And now I'm going to plot C, which is 5, 0. So I go out to 5 and up 0. Make sure when you're in geometry, you actually put the name of the point there because it is needed. Sorry that when I connected them, it's not perfectly straight lines. On this app, I can't draw straight lines, sadly. If I was on Notability, I could. So here's how we're going to do it. I have 3 side lengths. I have side AB, side AC, and side BC. So what I like to do is I like to make like a little organizational. And what we're going to do is we're going to find the distance of AB, the distance of AC, and the distance of BC. So I'm going to write out those 3 things right here. So the first one we're going to do is we're going to find the distance of AB. So the distance of AB, we're going to color code it. To find your distance of AB, you're going to do D is equal to, always rewrite that formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. What I'm going to do is I'm going to actually copy and paste the points A and B next to AB. That way we can refer back to them. And now I have 1, 3, -2, -1. So the first thing I'm going to identify is my x1 and my x2. So if my second x is -2, my first x is 1. So I'm going to be finding D is equal to the square root of my second x is -2, my first x is a 1, and I'm going to square it, and I'm going to add my second y, which is a -1, and my first y, which is a 3. So I'm going to do -1 minus 3. I'm going to square it. I have to ask myself, what's -2 minus 1? Well, -2 minus 1 is -3. So I have -3 squared plus -1 minus 3, which is -4. I'm going to square -4. Well, -3 squared is 9, so I have distance is equal to the square root of 9 plus -4 times -4 is 16. So I know my distance is going to be D equals 9 plus 16 is 25. So I have the square root of 25. If you go to your calculator and type the square root of 25, you're going to get 5. So my distance of AB is just 5. So the length of that line segment is just 5. And let's put a cloud around it. Now what we have to do is find the length of segment BC. Let's find the segment of BC right now. If you want, you can pause the video right now and try to find the distance of BC yourself. Or if you're still a little stuck, let's do it together. So I have to identify my second x value and my first x value. I'm going to put those in green. So my second x value is a 5, and my first x value is a -2. So when I make that substitution, I have distance is equal to the square root of 5 minus a -2. I'm going to square that whole thing. Again, make sure you put your negative numbers in parentheses because I don't want you to write 5 minus 2 thinking you did 5 minus a -2 because that's actually just 5 plus 2. So now I'm going to add my second y value, and in this case my second y value is 0, and my first y value is a -1. So I have plus 0 minus a -1, and I'm going to square that. So I have distance is equal to the square root. 5 minus a -2 is 7. So I'm going to square 7. 0 minus a -1 is 1. So I'm going to do 1 squared. And now I have to ask myself, what's 7 squared? Well, 7 squared is 49. So I have 49 plus 1 times 1 is 1. 49 plus 1 is 50. So I have D is equal to the square root of 50. Thing is, we need to see if we can simplify that. So let's do our double on the inside, single on the outside. If you know the quicker way, you can do the quicker way, where you just look at your perfect squares. But a majority of you know the prime factorization way. So let's do the prime factorization way. So I have 25 and 2, and then 5 and 5. Circle those primes. 5, 5, and 2. So I can say I have radical 5 times 5 times 2. Double on the inside, single on the outside, so I know I have 5 radical 2. And that's my distance for BC. It's all right to get radicals in your final answer. It's 100% fine. The higher the level of math you take, the more radicals there are. It's also a lot more fun. Now we're going to find the length of our final segment, AC. We're now going to find the length of side AC. So we have our points listed. We have A is 1, 3, and C is 5, 0. We're now going to make those substitutions into our distance formula. So D is equal to the square root of my second x minus my first x. So I have to go to my image and figure out my points, and figure out what my second x is and my first x is. Well, my second x is a 5, and I'm going to take away my first x of a 1, and then I square it. I'm then going to add my second y of a 0 minus my first y of a 3. Ooh, I'm going to have to deal with some negatives. Well, I have to say to myself, what's 5 minus 1? Well, 5 minus 1 is 4, so I'm going to be doing the square root of 4 squared. And I always put that answer in parentheses, even if it's positive, even if it's negative, just so I can be cautious. So 5 minus 1 is 4. Now, I'm going to do 0 minus 3. That's a negative number, so make sure you keep note of that. So plus negative 3, and I'm going to square that. And now I'm doing distance is equal to the square root. Well, 4 squared is just 16. Negative 3 times negative 3 is 9, so I have 16 plus 9. Well, 16 plus 9 is 25. So I have D is equal to the square root of 25. If you type the square root of 25 in your calculator, you get 5 as your final answer. And again, what I'll do right now is I'll go to the side. You won't see it in real time. I'll pause my video and put in the answer. I'll show you how to find the square root of 25 using the double on the inside, single on the outside. And boom, there it is. I broke apart my radical 25 into 5 times 5. Both those numbers are prime, so I circle them. I then put them under my radical, and remember, double on the inside, single on the outside. So now that I found all my side lengths, what I'm going to do is I'm going to go back to my image and label my image. So I know that side AB is 5, so I go to AB and I put a 5. I know that side AC is also 5, so that means that those two sides are congruent. And then I have side BC, which is 5 radical 2. What I want to do is find the perimeter of triangle ABC. So to find your perimeter, you simply just add up all your sides. So what we're going to do is we're going to say our perimeter is the sum of your sides. So I'm going to have 5 plus 5 plus 5 radical 2. We're going to combine our like terms. So 5 plus 5 is 10. So I have perimeter equals 10. And I don't have any other radical 2, so there's nothing for me to combine with my 5 radical 2. So I'm just going to write 5 radical 2. So my perimeter is 10 plus 5 radical 2. And that's your final answer. So I know that question took a while, but it really makes you understand how to use the distance formula. That's why it's called a digging deeper. So if you have any questions, please attend office hours with myself, or attend geometry support with Miss Daniel during second period on Mondays, Wednesdays, and Fridays. Zoom is on iLearn. And as always, if you have any questions, please email myself or Miss Daniel. And last but not least, make sure you work on your quiz review on Monday. Ladies, have a great, great day.